So let's start with what is a function. A function takes an input, processes it, and produces an output. In terms of notation, there are two main ways to write a function. One way is to say f of x equals, and the other way is to say f colon x arrow. We can think of functions as machines. So let's say we've got our function here, and I'm going to say that it is 2x plus 1. This is our machine. It's going to take an input, for example, 2, and it's going to do 2 times 2 plus 1, which will give us an output of 5. Input 2, output 5. Another way of thinking about this is we can say x equals 2 goes in, and then f of x equals 5 comes out. If you think about that on a coordinate axis, then x equals 2 would go in and f of x equals 5 comes out, but you can also think about that as y equals 5 comes out. Let's have a look at another example. In this example, f of x is 2x squared take away 10, and we want to find f of 3. The 3 inside the brackets there tells us that 3 is the input. So wherever we see an x in the function, we're going to want to replace that with a 3. So in this case, that will be 2 times 3 squared minus 10, which is 2 times 9 minus 10, which gives 8. For part B, it's really similar, except now the input is minus 2. So that will be 2 times minus 2 squared, take away 10. 2 times 4, take away 10, which is negative 2. Okay, so now that we've had a look at functions in general, let's talk about composite functions. Composite functions are 2 or more functions being applied in a row. The second function will take the output of the first function as its input and then produce a new output. So let's say we've got 2 functions here, so f of x equals 2x, and then let's say g of x equals x plus 3. 2 machines side by side. If we put 4 into the first f of x machine, then it will do 2 times 4 and 8 will come out. G of x will then take 8 as its input and do 8 plus 3, giving 11 as its output. In terms of notation, we can say gf4 equals 11. I'll explain where this comes from. So composite functions look like this, 2 letters next to each other representing the 2 functions. Now it's gf of x because g is taking f of x output as its input. So if we put brackets around the f of x, we can think about that as g of 2x because f of x is 2x. And if you put 2x as the input into g, you're going to get 2x plus 3. And then if you put 4 into that new composite function, you get 2 times 4 plus 3, which is 11. Let's take a look at some more examples. Given that f of x is equal to 3x plus 1 and g of x is equal to x squared, find f of g of x. First thing I like to do is to rewrite it with a second set of brackets so that I can see g of x is going to go into f of x. That means we're going to have f of x squared. And if we put x squared as the input into f of x, we get 3x squared plus 1. For part B, it's the other way round. So we're going to take g and then brackets f of x. So f of x is now the input into g. So g of 3x plus 1 is 3x plus 1 all squared. For part C, we can use our answer to part B to help us. So instead of x, this time they specifically want us to use 2 as the input. So if we look at part B, wherever we see an x, we're going to replace that with a 2. So that will be 3 times 2 plus 1 all squared, giving 7 squared, so 49. Another way you can think about that if you want is you can start with just f of 2, so putting 2 as the input into f, giving 3 times 2 plus 1, so 7. And then you can take that 7 and stick it into the g of x. So that way we can say g of 7 equals 7 squared, which is also 49, whichever way you prefer. Another example, so this time f of x equals x over 3 plus 4 and g of x equals 6x squared plus 3. And they want f of g of x. So sticking our brackets in there, we're going to take g of x and put it into f of x. So that's going to look like 6x squared plus 3 over 3 plus 4. That looks messy, so let's see if we can tidy it up. So we can divide each of those things by 3, which would give 2x squared plus 1, and then the plus 4 on the end. Tidying that up gives 2x squared plus 5. Let's talk about inverse functions now. An inverse function does the reverse or opposite to the function that it came from. So once again, if we think about a nice simple example, let's say f of x is equal to 2x. If that's our machine and we put 3 in, then 2 times 3 is 6. That's what's going to come out there. So our input is 3 and our output is 6. Now, for an inverse function, we want to do the reverse of that process. So thinking about what the reverse of doing 2 times x is, that would surely be x divided by 2. In terms of notation for inverse functions, we do f to the power of minus 1x, like that. So because it's doing the reverse process, this time if we put 6 in, 6 divided by 2 will give us 3 coming out. So we definitely have reversed the process there. In other words, 6 now becomes our input and 3 now becomes our output. Now, that was a fairly simple example that we could think about in our heads in terms of thinking about what the reverse would be, but there is a method that you can do to work it out for more complicated functions. I'll show you the method on that easy example that we just did, and then we'll apply it to some more difficult ones. So in that example we just had, we had f of x is equal to 2x, and we want to find the inverse function. So find f of minus 1 of x. Here's the method. So step 1, you're going to replace f of x with y. As it says there, instead of writing f of x is equal to 2x, we're going to write y equals 2x. Step 2, we're going to make x the subject. So in this case, we're going to divide the y by 2, and that will give us x on its own as the subject. Step 3 is a bit strange. We're actually going to swap x and y around. So literally just x over 2 equals y. Now, the reason behind that is to do with the whole switching of inputs and outputs thing that we saw previously. Final step, step 4, write your answer by replacing y with the notation for inverse, so with f of minus 1 of x. So our answer is going to be f of minus 1 of x equals x over 2. Just like we saw, that's the reverse process, reverse function, inverse function. Let's take a look at some more complicated examples now, and we're going to do that 4-step process for these ones. So step 1, we said we would replace f of x with y, so let's do that. Step 2, make x the subject. So let's maybe add 1 and divide by 4. Step 3, do that swapping process, so swap the x and the y around. Final step, write down the answer by saying f of minus 1 of x equals x plus 1 over 4. Final example, given that this time f of x is equal to x squared minus 17, find the inverse function. Same 4-step process. So for step number 1, we're going to say y equals x squared minus 17. Step 2, we want to make x the subject. So add 17 to both sides. And then to get x on its own, the reverse of squaring something is square rooting something. So let's put our square root symbol over the whole of y plus 17. Now, usually when we square root something, we get 2 answers. We get the positive square root and the negative square root. But with inverse functions, you actually don't care about the negative. You only want the positive square root. So now for step 3, when we do that swapping process, we're going to swap the x's and y's around. So x plus 17 equals y, just the positive square root. And finally, write our answer for step 4. And there we go. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already. And definitely share this with anyone else who you think might find it helpful. Thanks, and see you next time.